the three primary things that we've done in version 2.0. Okay, so let's run through these kind of quickly so that we can eventually get to the software itself. For the service life uncertainty, we're using a technique from the University of Toronto, Evan Bentz in particular, where you can modify these 5 values. You can select these 5 values, what's selected by the methodology rather. What it does is it modifies each of these. It modifies that initial diffusivity of the concrete, the chloride diffusion would be at the initial onset. It modifies this decay parameter, which this value of m, which simply is a value that that models how the diffusivity goes down over time. As the concrete matures, it becomes less porous to chlorides, and so we're capturing that. Surface chloride concentration, what we're using for a value is very likely not to be what the structure would experience in the field, even though we have regional values. So it modifies that value. It also modifies the chloride level that initiates corrosion, and then modifies this depth of reinforcing. It does a series of calculations, and then computes these different density functions, the different probabilities of a service life. Here it's showing for the red case that the highest probability of this case, base case, occurs around 15 years, and then it drops off. In the case of the blue alternative, it's much wider. This is one that has I believe, SCMs involved with it. So it has a much more variant service life. And then here at the bottom, it just sums up all of those individual probabilities and gives you the cumulative function. Okay, very quickly for the life cycle costing with sensitivity analysis, here in the upper corner it's showing you the traditional results that came out of even version 1.1 of Life 365. So you do your life cycle cost calculations, and here it's showing you a comparison between a base case that has a total life cycle cost of approximately $17 per square foot of the structure. In this case, it's a slab, compared with an alternative that has clearly it has a barrier or sealant involved, where its total is less. It's about $14 a square foot. The construction cost is about the same. Alternative one has slightly higher. It includes a barrier cost here of roughly $3 a square foot. And the repair costs are lower. And the reason for that is that by having a longer service life, you have fewer repairs. So the version 1.0 answer would be, here's your base case life cycle cost, here's your alternative one, and here are the components. The sensitivity analysis allows you to, let's just take one example here. These calculations, these results are based on specific inflation rates and specific discount rates. Inflation captures the increased price of materials, labor, and other construction costs over time, so that 20 years from now, for example, the cost of concrete is likely to be higher, and you want to capture that over the life of a structure. Sensitivity to inflation rate, what it allows you to do, looking at this diagram right here, what you can do is take these results and then recompute the service life, each time modifying your inflation rate. So raise the inflation rate and you're going to get a higher value over here. Lower the inflation rate and recompute the life cycle costs. The red line here is the life cycle cost of that structure for each one of these changes in inflation rate. And the blue line is the life cycle cost of alternative one. The point here is that no matter which inflation rate we've chose, we see a lower life cycle cost of alternative one when compared to life cycle cost of the base case. So we're able to say that regardless of the inflation rate chosen for variations that you're going to see in the field, alternative one will remain life cycle cost effective. And you can do the similar things for the discount rate. Things get interesting when you have crosses here. So under the under the best guess values, the ones that are your initial cuts at those values, you'll see that the blue line is lower, but when you start lowering repair costs, then eventually the alternative one mix, the one with the corrosion protection strategy, has a higher life cycle cost than the base case. And the reason for this is that alternative one is giving you fewer repairs, but if the cost of the repairs goes down enough, you're losing that benefit of alternative one of reducing repair costs. You end up having to pay, you're getting to the point where the additional barrier cost and the additional construction costs are outweighing the benefits of the repair. So these graphs allow you to see at what point those changes in underlying parameters will affect your outcome. Is it still the case that that alternative one is, well, the life cycle cost effective choice? It's not if the repair costs get low enough. So the software provides you means for doing that. Here's a navigation panel on the left. When you want to save a project, close a project, um, go through the various steps, get help on your project, this navigation panel is meant to be almost like a web page that has a navigation panel. That's always there and allows you to know where you can go from here. To complete a project, you have to complete each of these tabs. Here's the project tab, exposure tab. These are environmental conditions. This allows you to make your concrete mixtures. Here you compute your project costs. Here it computes the life cycle costs for you. And then there are some reports as well. And then each one of these screens, particularly when you get to some of these terms that may not be completely familiar to you, when you hover over the term or hover over the field, it's going to give you information here on the left about what that field means. So again, for example, if you're not familiar with what the term M means, or not familiar with what the propagation period is and how it's computed, by hovering your mouse over these, it's going to update this information, and we'll see it in the software. Also, each one of these graphs, typically these graphs you can copy to your clipboard and paste into Microsoft Word or PowerPoint. You can export the raw data itself for use in other applications. Most of these fields that are tables or graphs, you can directly grab that information and put into your own applications. So very quickly you can come up with a report based on your Life365 analysis. It also includes 2 standard reports, and we have other means for making additional reports in the future if there's standard information that comes out.